Hello and welcome to episode 64 of Linux Downtime. I'm Joe.
I'm Martin.
I'm Hayden.
I'm Gary.
Nice to talk to you all again. So today I want to talk to you about trust and trust of software. Now, traditionally, I have always just trusted my distro. In my particular case, it's Ubuntu. And so I'm kind of trusting the Ubuntu team and Canonical. But, I'd be happy to trust Fedora and Red Hat or SUSE. But the reality is that's not where a lot of software comes from these days. It doesn't necessarily come from your distro. It comes from containers and snaps on Ubuntu, Flatpaks. And it got me wondering, how do we trust the software that we use, the open source software that we use? And I don't necessarily mean how do we trust it not to be malicious, because I think that that's fairly uncommon. But what is more common, I would imagine, is software that isn't necessarily put together brilliantly and isn't necessarily up to date and may have vulnerabilities in it. So in this modern world, how do we trust the open source software that we use?
You said you trust your distro, but where are you installing the software from for your distribution, and how do you even know that there is any kind of trust to be given to the software that you're installing?
Well, traditionally, I've always stuck to just what's in the distribution's repositories. So I have always, perhaps naively, trusted that that's curated to a point where I can trust it.
Okay, and there's some truth in that, but there's sort of different levels of not just curation, but also sort of oversight. So if we take Ubuntu, for example, there's the main repository, which is the software that Canonical ship by default in Ubuntu, in the official version of Ubuntu. However, the Ubuntu flavors are exempt from that restriction, and they can include software from the Universe archive.
Yeah.
And that has, when I say no oversight from Canonical, that's not necessarily true. There are some people that work for Canonical that will maintain some of the software that's in the Universe archive. But generally speaking, the Universe archive is entirely community maintained and is not subject to the same rigor when it comes to patching security issues, known security issues, as the main repository, which has SLAs applied and all high and critical vulnerabilities there get remedied. And I know that, you mentioned the other distros. I know that SUSE and Red Hat / Fedora have similar policies in the way that their archives are managed and organized.
Yeah, I remember VLC, for example, had a subtitle vulnerability, and that didn't get patched for ages until someone in the community did it.
Right.
Because it was in Universe.
Now, that was some time ago, because I know that Canonical have got a relatively new initiative where they are looking at a large slice of the packages in Universe, and they're actually trying to keep those security patched as well. And I think that's part of the Ubuntu Pro bundle of add-on services and what have you.
But most distros have this two-tier approach. I mean, Fedora, Red Hat, and the rest of Enterprise Linux have EPEL. And then even the SUSE distros, you can easily add additional sources for packages from the Open Build service, similar to Launchpad and PPAs there. So every distro has this two-tier system where you have the secured packages that are part of the base distro, and then other packages.
Yes and no. Debian doesn't have that. Debian just has the main, this is our repo. It's only maintained by Debian. I mean, likewise, you can add PPAs galore. I mean, what you don't call them PPAs in Debian. But like Debian also has their own security branches for their LTS to make sure you're up to date, stuff like that. And they have a whole security team. So like from that point of view, I think they're doing all right. But everything goes through Debian maintainers, which is also one of the reasons why packages get slowed down, is because it's always has to go through all the maintainers.
So I think what we've established here is, yes, the distributions have slightly different policies for different packages depending on where they come from, and different levels of oversight, but that's probably opaque or unknown to most users of those distributions. And I imagine that if they want to install VLC or LibreOffice or Pidgin or any other open source software, they will just use insert name of Software Center or Package Manager GUI and just hit the install button without thinking about it.
Yeah, I actually ran into an interesting situation with this with a user recently. Their distribution had an old version of Pidgin that they were hitting a bug with. And I was like, well, if you have Flatpak available, there's a newer version there. But it's like I have to tell them and make them aware that there's another way to install it that could be more up to date.
And I suppose what I'm interested in is, why is this discussion about open source software? I mean, obviously the name of the podcast kind of gives it away a little bit, but in this modern world, which is how you set this out, Joe, I think all of us have got a smartphone of some sort or another, and we will be installing apps from a central app store, let's call it. And there are similar approaches with the likes of FlatHub and the Snap Store and what have you to sort of create central repositories where the dynamic is different. Instead of having a collection of volunteers curating a large archive of software, you now have the developers of said application publishing their software directly to the consumers.
Well, I think the reason that we're talking about this in terms of open source software is that one of the big benefits is that the source is open. It can be studied by people, at least in theory. And it's not like proprietary software where you just have to put 100% trust in whoever's making it. You can, in theory, look at the source code, pay someone to look at the source code. Whether that actually happens or not is another story. But there's almost an assumption that you can trust open source software. And less so necessarily with snaps and flatpaks, but also with containers and things. Say you just pull a Docker container down from Docker Hub. How have you got any idea whether that's configured correctly and it isn't going to be full of security holes?
From an enterprise perspective, we've seen the adoption of things like software bill of materials, SBOMs, the standardization of like the SPDX format. And when it comes to enterprise and government procurement, those are now standard fare to get those from open source projects. And I've increasingly seen those trickle down to community open source projects who are beginning to publish information on the provenance of their dependencies, policies on how quickly they're patching CVEs, and that trickle down from enterprise to more community-based and like the upstream projects that become the enterprise projects.
Yeah. This is all relatively new. Within the last sort of 12 to 18 months, there's been sort of heightened endeavor around, well, I think was it the DoD in the US that basically said that they couldn't accept any software delivered as containers that contained any known vulnerabilities, which is actually a very high bar to clear, to actually ship a container with no known vulnerabilities in it whatsoever. But that focused everyone's attention. And as Hayden says, there's sort of this dynamic, and it's a bit like the App Store dynamic when we were talking about smartphones, of container producers and container consumers. And there is now sort of downward pressure from the container consumers to the producers to demonstrate that their containers are of high quality, that there is a software bill of materials, that there are vulnerability assessments, that those are updated and maintained. And so we're seeing this sort of shifting of expectation onto developers who create these containers.
So we faced this challenge at Rancher as manager of the internal DevOps team. We were challenged to scan the dependencies in our images that we publish, including the main Rancher container image that has been pulled millions of times from Docker Hub. And we looked at our options and we identified a tool called Fossa. And we built Fossa into our CI/CD pipelines. And it actually be interesting there. It's an open source, but SaaS based. And it scanned the dependencies at build time and gave us a pretty clear picture into vulnerabilities in dependencies. And a project like Rancher has a couple hundred repositories and several thousand dependencies. And it required significant automation to identify and then begin to patch those critical vulnerabilities. But for smaller scale projects, you see things like Dependabot and other tools making their way into GitHub, and maybe Gary can speak to GitLab and tools that may be there.
Well, I don't use Git, so I don't use GitLab either. But I know of Dependabot, but I thought Dependabot only did like Node.js stuff, but maybe I'm just ill-informed there. But yeah, I'm not aware of anything else for it. I mean, historically for like desktop Linux applications, this has always just been something we leave to the distros. And this is one of the problems we're talking about too, right? Using SBOM or something like that, we would know what our dependencies are. One of the things we're trying to do with Pigeon 3 is we're trying to control all of that so that our Windows, our Mac, and our app image or Flatpak or whatever builds we end up creating for Linux, all of them will have the same versions. But that's more important to us from a support point of view, because it's really difficult to figure out when a user's encountering a bug when it's based on one of the libraries that they have because it's an older version, right? That's really hard to reproduce. So if we can control all of that, we can just avoid that scenario. So that's one of the reasons why it's important for us to do it that way. But I don't want to say we're not considering the security point of view of it. Just there's other options or there's other opportunities there as well where SBOM and stuff like that come in handy.
My apologies for accusing you of using Git. I know how you feel about GitHub, but I think Trivy is another popular open source scanning tool as well.
Yeah, Trivy and Gripe are both open source vulnerability scanners. And at my old job at Slim AI, we'd integrated both of those into the platform. So when you inspect your container images, it will analyze the vulnerabilities with those tools. But the neat thing is that what they've developed now is the ability to, on those optimized hardened containers, which has stripped out a whole bunch of stuff you don't need, is run the same vulnerability analysis and see what vulnerabilities are left behind in these tiny containers at the end, and then trend that over time. And I suppose all of this conversation is really, Joe, it's not just about people looking at code anymore, because the problem is scaled beyond human endeavor. So the industry is creating a whole bunch of tooling and automation to actually do the heavy lifting so that the humans at the end of the day have got an easier task of actually prioritizing and deciding where the vulnerabilities and where the attention needs to be given in order to ensure that the software they're shipping is secure.
We use Faucet at build time at Rancher, and then after it was built and the container was packaged, before it was shipped, it was then scanned again with Trivy on the way out. Of course, part of that was then rebasing to SLE BCI. And I think, particularly in the container space, the use of minimal containers, maintained base container images, either from Red Hat or SUSE, or now even distroless containers,
right,
will further reduce the attack surface.
Where does reproducibility come into all of this? Because surely that would make it easier if the software can be built to be exactly the same binary every time.
So reproducibility and repeatability are two different things. And I see a lot of developers who are working with containers conflating the two things. So reproducibility is, if I send you my build configuration, Joe, the thing that you end up with is bit for bit identical to the thing that I built here on my system.
Yeah.
Now, if we just look at Docker by comparison, Docker is repeatable. I can send you my Docker file. You can repeat the same steps on your system, but there is no guarantee that what you have in your container is the same as what I have in my container. So there are different ways to address this problem in terms of what are we shipping into production? This is really what people care about. So as an organization, if you're a financial organization, you need to be able to prove that you know what you're shipping into production. So you need to have your software bill of materials, and you need to have your audit from your CI/CD, and you need to sign your containers and then demonstrate that all of the containers that you've deployed into production are in fact this same container that was signed and went through this whole chain. Now, that's basically a whole bunch of tooling to solve the problem that Docker containers are not reproducible. And this is where we then start to look at, solutions like Nix, where that has got a reproducible guarantee all the way through. And this is why you're seeing some organizations using Nix to produce their containers, because there's absolute guarantees about what you've just created, wherever you created it, whoever created it. So long as it came from the same configuration, they've got the same stuff.
Now, before we started recording, we were talking about SBCs, single board computers, and ARM devices generally, and how for some of them, some of the lesser known ones, let's say, the software support is patchy. And that makes me worry as well. Like, if you've got a single board computer that isn't really supported by many images anymore, and you need a bespoke image for it, and then you just find something linked off some forum somewhere, how can I possibly trust that?
Well, you can't, Joe, but in much the same way that you couldn't trust, say, an ancient lineage image that you're installing on a Nexus 7 or something like that. You know, if you've got an old device, that board support package has got a shelf life beyond which you can only run up to a certain version of like the Android-based system or some other ARM-based distro. Just the other day, I was fiddling with our Amazon Echoes, trying to get the three of them to harmoniously cooperate. And I discovered that two of them are beyond security support, and they haven't been supported for some considerable time. And I had no idea.
So getting back to your more, how do you trust this random thing on the internet? We've had a solution for this since the 90s. It's not ideal. People have complained about how it works, but it's PGP. It still exists. You can still build a web of trust. People can still sign images. It all still works. It's all still there. It's still hard to use. But like, I still sign all the Pigeon releases with my PGP key because there's people who I've signed keys with. They can verify it came from me. People have actually met me, verified my key. They know that it came from me.
Is that the source code that you're referring to, or the binaries as well?
On Linux, we just release the source code, but then we also provide binaries for Windows. I sign all the source code and all the Windows binaries, but the Windows binaries also have a code signing cert on them. So you can check as much as you want.
Yeah, I mean, I do the same with images of Ubuntu Mate. The ones that are produced by Canonical are signed with the Canonical keys, and the ones that I make, I sign with my own keys, and I publish that along with instructions on how to validate them. I suspect almost nobody actually checks the integrity or provenance of those images after they've downloaded them.
Do they even do the checksums on them?
No. According to my download stats, they don't download the checksum or the PGP signature. But it's there if they want it.
Yeah.
Well, that comes back to the whole thing of open source, doesn't it? That in theory, that source code can be viewed, but people just don't, do they? They just trust. They trust someone who trusts someone else, and there's this chain or web of trust. And it's kind of all built on this goodwill. And I wonder if that's enough.
Is it trust or is it laziness, though? And I don't think it just applies to, the open source community. Because if you've got a Windows computer and you want a piece of software, you search for software that does what you want, and you go to some website and you download a thing and you install a thing. And I don't think many people think long and hard about the software that they're downloading and installing, in the same way that probably a lot of Linux and open source enthusiasts don't think too long and hard about the curl pipe to bash commands that they're running from, random websites.
To be clear, I never run curl to bash. I will actually go and read the bash script and run the stuff manually, because I once saw a proof of concept where they could determine if you were piping or not. And I'm just like, yep, not going to happen. Not going to take that chance.
Well, do let us know your thoughts on all of this. You can email us show@linuxdowntime.com. But we'd better get out of here. We'll be back in a couple of weeks. Until then, I've been Joe.
I've been Martin.
I've been Hayden.
And I've been Gary.
See you later.